All right, so we are going to be talking about graphing exponential growth. The equations look like this. We have y equals a multiplied by b to the x power. Let's look at this. If I have y equals 2 to the x power, that's basically the same thing as saying y equals 1 multiplied by 2 to the x power. And that's important to see because I was saying that it was of the form y equals a times b to the x. So we just want to kind of be aware of what a is in this case. If I were to take negative 2 and plug it in for x, I would get 2 to the negative second power. Well, that's a negative exponent, so that's 1 over 2 squared, which would be 1/4. If I were to take negative 1 and plug it into the function here for x, I would get 2 to the negative first power, which is 1 over 2 to the first because of a negative exponent. That's 1/2. 2 to the 0 would be 1. 2 to the first would be 2, and 2 to the second would be 4. Well, so we go ahead and graph that. And it looks something like this. And what I'm going to tell you is, had we chosen even more points, the graph would look something like this, and it would never end up hitting the x-axis. So because of that, we say that there is a horizontal asymptote at y equals 0, because way out at the end here on the left, it kind of narrows in on 0. That's where that horizontal asymptote is coming in. The domain of this is all reals. All of the x values are going to get used. However, this graph will never hit 0 because there's no possible way I could raise 2 to a power of anything and get an answer of 0. And it will always be above 0. So y is greater than 0. Okay, well, what if we took y equals 3 times 2 to the x? So now a is 3. Just keep that in mind. Well, so I would take 3 multiplied by 2 to the negative second power, which is 3 multiplied by 1 over 4, 3/4. 3 times 2 to the negative first power is 3 multiplied by 1 over 2, which is 3/2. 3 times 2 to the 0 is 3 times 1, which is 3. And what would happen is we would get 6 and 12. So graphing that, notice at 0 it crosses at 3 this time instead of at 1. And each time we move to the right, we multiply that by 2 each time. And that's because 2 is the thing that is being raised to the power. We still have that horizontal asymptote at y equals 0. Our domain is still going to be all reals. And the entire graph is going to be above that horizontal asymptote, so y is greater than 0. Well, rather than having us plugging in points nonstop to find out what these graphs look like, we're going to simplify matters a little bit. So we are going to focus on only 3 points. These are going to be our steps that we're going to take, and I'm going to go through these steps in each one of our problems that we will see in this particular section, and then we'll do the same with decay and something else. So first thing, we're going to look at what A, B, and C are. A was that number out front. B is the number that's being raised to the power, and C may be a number out at the end that's either being added or subtracted at the end. When we set up our table, we're going to start off and we're going to use -1, 0, and 1. This is kind of considered to be your parent table. And what we're going to put in those spots underneath the y are going to be whatever a divided by b is, what a is, and what a multiplied by b is. And again, then we may adjust the table because this will be our parent. If we're going to change the x's, we will know because the place that will change the x's will be right up here in the exponent. Those that's where we change the x's. That would be considered to be your inside. If we're going to change the y's, it will be whatever happens out here with the c. So maybe we add, maybe we subtract. The horizontal asymptote, this was key. This is always going to be y equals whatever c is. That's going to be our asymptote. We'll plot the points, draw the curve, and our domain will always be all reals because it's going to extend to the left and to the right. And our range will relate to the horizontal asymptote. It will relate because the entire graph will either be above or below that horizontal asymptote. Lastly, because this is exponential growth, what I'm going to know is that moving from left to right in the graph, it's going to grow either more positive or it's going to be growing it will be growing more negative. So because you're having an exponential growth problem, it will grow from left to right, just may grow more negative than more positive. So let's try these. What I see here is I see that A is 3, B is 2, and C is 1. Our parent table would be -1, 0, 1. At 0, we're going to put whatever A is. At 1, we're going to take A and divide it by B. I'm sorry, at -1. And at +1, we're going to take A and multiply by B. So I wrote 3 times 2. That will actually be 6. Okay, let's look here. Anything up in the exponent that's going to mess with the x's? No, it's just an x. So we're not going to change our x's. Over here, that's going to change the y's. And we're going to change the y's in the exact same way. So we're going to add 1 to that. So 3 halves plus 1 is 2.5, because 3 halves is 1.5. 3 plus 1 is 4. 6 plus 1 is 7. If you remember, our horizontal asymptote is always going to be what c is, so y equals 1 will be our horizontal asymptote. All right, let's graph that. So I have y equals 1. I have -1, 2.5. I have 0, 4. And I have 1, 7. I know this is growing from left to right, so it's going to get more positive. I have that the domain is all reals, and the range, since this graph is above the horizontal asymptote, is y is greater than 1. All right, let's try another one. Here, A is 3, B is 2, and C is -4. Start off your table, -1, 0, and 1. And next to 0, I'm going to put whatever A is. Next to -1, I'm going to take A divided by B. And next to +1, A times B. What happens in the exponent? We do the opposite to x. So I'm going to go ahead and add 1. What happens out here is what I do to y. So I'm going to subtract 4 from the y's. And remember, that's also our horizontal asymptote. So going ahead and adding 1 to the x's, I get 0, 1, and 2. Subtracting 4 from the y's, this gives me -2.5, -1, and 2. And let's graph it. Y equals -4, 0, -2.5, 1, -1, and 2, 2. This is exponential growth, so it's growing as I move from left to right. The entire graph is above that horizontal asymptote, so y is greater than -4. Range is always all reals. All right, last example. A in this case is -2, B is 4, and C is 1. Set up your table, negative 1, 0, and 1. At 0, I'm going to put A. At negative 1, I'm going to take A divided by B, so negative 2 divided by 4, which is negative 1/2. And at 1, I'm going to take A times B, which is negative 8. In the exponent, we're going to go ahead and add 2 to the x's because we do the opposite. Hanging out here, we're going to add 1 to the y's because that's exactly what we do to the y's. And that's also our horizontal asymptote. So let's see, I get 1/2, negative 1, and negative 7, I believe. Let's graph it. Y equals 1, positive 1, 1/2, 2, negative 1, and 3, negative 7. This thing is growing from left to right. It's just that this time it's growing more negative. Domain, all reals, always all reals. And range, this time since the entire curve is below that horizontal asymptote, y is less than 1. All right.